All right, thanks everyone. Welcome to the talk. This is titled Don't Page Me, and it's about how my team limits pager noise. I work at New Relic. My name is Chuck Lauer Vose. I go by he, him pronouns. I've already forgotten my instructions. There's slides at the bottom of this. I realized when I got out to about the halfway point, there is some little tiny code on the screen that you're probably going to want to look at. So if you can't see it, or if you're visually impaired, or whatever reason you need, the slides are there. So yeah, my name is Chuck Lauer Vose. That's my email. You can totally email me. On the internet, I am at Vosichu, pretty much everywhere. Except I found out the Pokemon forums, where it seems like everything ending in Chew is taken. So we've got a booth open tomorrow, and I'll just say now, we would love to help you with any of these topics. So come on by. I'll be there frequently. We can talk about everything that we go over today. This is our corporate mandated legal slide. It's how you know you've made it, right? Okay, so if you've been to any of my talks before, you'll know that I love a good activity. And I just need something to get the brain going. So this talk is all about getting to the point where our team gets paged about once a month. And so I think if you're excited by the idea of a week without pages, I would just ask you to stand up for a moment and I don't know, get long, get some blood flowing, shake up. And then kind of get hyped and get ready for the 30-second dance party.
Dip Chuck, Dip Fantasia.
Thank you. I really needed that, honestly. I'm ready now. Let's go. So I'm excited to talk about this. This is a culmination of, I guess, 8 years of thinking about incidents and pages and stuff like that. I was an incident commander at my previous company, and I do a lot of incidents at this company. My team runs api.newrelic.com, which is a pretty big site. We have 40 externals. We have 13 data stores. By all accounts, we should be down all the time, right? And we were. 3 years ago. 3 years ago, we would get paged about 5 times a week, which some people will probably be thinking oh, that's fine. Now we get paged about once a month, and we have different problems. Now we have people coming into on-call. I don't know how to train them. That's success. I'll take that problem. Also, for the first time, I get to wear the Ruby cape, which is a company thing, and I'm just delighted to finally get to do this. It's been an 8-year dream of mine. So this has been great. So 3-point takeaway. If you remember nothing from this talk, I hope you remember these things, and we're going to talk more about them. I don't know that they're going to make sense yet, but you'll know what they are. So the first thing I want you to remember is that the notifications you receive during an incident, those deserve retros too. So that's the first thing. Second is that default alert conditions that you you click the add pre-built alerts or whatever, those always require refinement and extra details before they're viable. And the last one is that heartbeat monitors, which I'm going to talk about what those are, those really do save lives, not just in the medical sense. They will save you. So those are the 3 things we're going to cover. And this is the map. If I were joining your team right now, and we had a pager noise problem, this is where I'd spend time. First step, adding some basic alert conditions. They're going to be noisy and terrible, and it's going to make life a lot worse. Then we're going to build a culture of retroing those alerts, the alert conditions, as well as the incident. Then we're going to start refining it. These are separate steps. You actually have to have data in order to refine things. Otherwise, it's just faffery, I think is the technical scientific term. The last two steps, adding heartbeat monitors, which adds a ton of confidence to alert conditions. And then finally, now that we've gotten rid of all the false positives, we're going to talk about how do we actually reduce the number of incidents and the impact of them. Unfortunately, that last part I'm going to have to rush through because those are whole talks on their own, but we'll get there. Quick terminology, because the industry is varied. So when I say alert policy, it basically means nothing. They're a bucket for alert conditions. Alert conditions are the things that we evaluate and trigger events on. So if an alert condition is triggered, we might send a message to Slack, we might send it to PagerDuty, we might send it to both. Our team tends to send everything to Slack, but also sometimes to PagerDuty. And then these are my words. The industry definitely doesn't agree on these two, but I call the things that you send to Slack, the kind of lower trust but still important, I call those things notifications. And the ones that I really want to wake me up in the middle of the night, I call those alert notifications. They're kind of a subset. I will admit that I'm probably going to screw up. I think I've already done it twice. I may say just the word alerts. Generally, I'm talking about alert notifications, but not always. I'm going to try not to, but we'll see how it does. So that's all the terminology you need to know. So first step, let's make it worse. This is an unfortunate step, actually. We really do make it a lot worse. So we're going to add some like default alert conditions in whatever APM product you have. It actually does not matter at all. The process is going to be the same. And we want to rush through this as quickly as possible because we need to get on to a better life. But we genuinely have to get some kind of alerts so that our customers are not the ones informing us that we're down, right? That's absolutely the worst. So New Relic has like a pre-built alerts button. That's going to be fine. No big deal. So pre-built alerts in most APM, they look something like this. Error rate goes up, panic. Throughput changes too much, panic. Request duration changes too much, panic. These all seem pretty reasonable, right? But the problem with the pre-built alerts is that while they're the best that any reasonable company can do without knowing a lot more about you, they're just not that good. For instance, let's debunk some of these. Single customer, I'm sure that you've all experienced this. Single customers can absolutely cause your error rate to just like skyrocket. But if all your customers are happy except that one, is it an incident? Like really? We have this all the time. We'll have big customers that are doing things very regularly. Every 5 minutes, they do this big batch job. When they stop, our throughput will like drop by 20,000 requests per minute. Like, is that incident worthy? It's just a customer doing something else. But surely, request duration, that has to be the sacred one, right? Well, I don't know about you, but I have a /admin in my website, and some of the stuff in there takes like hours. Like that will destroy my average duration. So I suspect that you do too. So it kind of turns out that none of these are actually reasonable things to alert on, or attach alert notifications to. So, but they are better than not knowing when an incident is happening. So that's why we have to start here. I really love this Seth Godin quote. Just because something's easy to measure doesn't mean it's important. And I think that this is something that our industry kind of runs into a lot. So we know this is true from testing, right? The easy test is not always the valuable test, right? Sometimes the good test is extremely hard to write, and alert conditions turn out to be exactly the same. The pre-builts exist because they're a good starting point, but they're limited because HTTP doesn't actually give us a ton of information. It certainly doesn't tell us about your situation. which status codes are important to your infrastructure, which status codes your load balancer is going to throw. It doesn't tell us anything about your customer data at all, right? HTTP doesn't know or care. It also doesn't talk about how resilient your code is. So just because it's easy to measure doesn't mean it's important. But that's all we have to start with, these like easy pre-built things. So I'm not saying don't do these. I'm just saying like don't assume that they're an emergency, because 90% of the time they aren't. Oh, that's in black. That's exciting. So step 2 of this is focusing on fixing the alert condition in addition to the incident. So I said 15% of time. That's a lot of time for this, but I think it's actually really important. So we have noisy alerts now. We need to start understanding what's happening, what kind of problems our customers run into, what things our alert conditions can't really seem to handle. I'm just curious to know, how many people feel like this is kind of where they're at in their company? Like you might twiddle the sensitivity on alert conditions, but you haven't done like extensive other things. Hands? Yeah. Like I think a lot of companies are actually exactly here. And it's hard to go further without a ton of extra data about what's really happening. So don't feel bad if your team is still at this stage. I think it is admirable that you're smart enough to recognize that the team has a problem and brave enough to look for new answers. That's awesome. It makes you good engineers. So this is what our team does. Every morning at stand-up, we talk about literally every single notification that came in, whether it's an alert or a Slack notification, every one of them. And we separate them into 4 buckets. Real incidents that needed our help, real incidents that didn't need our help, things that looked like incidents but turned out not to be incidents. Those are good ones. We're going to talk about these a little bit. And then the last one is just false positives. These shouldn't happen. They're going to be our first target. And then we record some metadata that I'm going to talk about in 2 slides. If you know me, you'll know that I believe magnets and spreadsheets make literally everything better. So if you want some bonus Chuck points, throw them in a spreadsheet. It really helped us, actually, seeing the trend lines as the number of incidents kind of went down and the different buckets kind of changed, was actually really instrumental. I was not involved in the decision to make a spreadsheet, to be clear. It was someone else, but I loved it all the same. So let's talk quickly about that like number 3 category, the false positives that feel real but actually aren't. I have this slide because this is actually the largest career regret that I have. Not recognizing the amount of damage that this was doing to my life and my marriage and my everything. These feel really good. They're incidents that don't harm anyone. They close really quickly. It's really tempting to just dig into these. And I spent years looking at these. I got really, really good at closing incidents that should have never started. You think about that, and it's kind of like mind-blowing. Like, I was prideful of being able to quickly like jump in there, do some research, figure out that this was not a thing. Yeah, job done. Like, I could have gotten a robot to do that, right? That's what computers are for. So I really regret that I didn't recognize these for what they were. These are a waste of time, even if they feel good, and they do. It is waste. So what are we going to do about it? We're going to let those robots do the work for us. We're going to start refining our conditions a little bit. So now that we have a team process for retroing alert conditions, we can actually act on the data that we've been collecting. Genuinely, we cannot do this step without doing the former. You must have data about what causes those noisy alerts. yeah, I just did it again, alert notifications. You have to have that data. So this is what we do. During an incident or a mini retro, we try and record these three things. Which condition triggered, how we knew if the incident was false, great data, and how you knew when the incident was over. That actually, sometimes you don't know that second one, but you can usually tell when the incident is over. And that's useful information to record. Once we have that recorded, we'll actually clone that kind of like general, the default alert condition. And we'll try and add those steps in, like right there. So in my product, we use NRQL for NRQL for most of our alerts, which is like, it's SQL. Like, it's SQL with a different shape. So when you see it, you probably will not be too terribly surprised. So we'll clone our thing, try and add in that automatic research, and then send that to Slack for a while and watch it. You'll see, I'll give you a great example of why you need to watch it for a while before attaching alert policies. And then the last step on this is that you make that old condition a little bit less sensitive. Maybe you go from 3 minutes of error rate to 4 minutes. Right now, one of our super general error rates is at 60 minutes because we've covered so many different cases that generally that one doesn't go off. And when it does, it's like, well, we made it for 60 minutes without anyone crying, so I guess we better look at it, but clearly it's lower urgency at this point. So we do this all the time. Let's do an example. This is a default alert condition on error rate. We're using a baseline, so you can see that, you may be able to see that gray border. That's an automatically adjusting threshold. And so if it exceeds some like velocity of change, it will trip the alert. These are fun. This chart only shows 6 hours, and we actually need a lot more. So I'm going to just throw this straight into NRQL. And this is pretty much what it looks like. The query looks gross. I'm not going to lie. It's a subquery. And on the next slide, I'm going to show you what that inner query is. But if you look at the subquery, you'll see that it's actually just summing one of the things that's coming back from the inner query and doing nothing else. So like it's actually a subquery that does nothing. I'm setting up for the next slides, okay? So this is what the inner query actually does. On the left, you'll see some error classes. The top one is a Hawthorne service exception. You don't need to know what that is, but there were 23,000 of those that happened during this time span. And in those 23,000 things, I'm calculating how many distinct user agents showed up in that list of 23,000, and how many distinct customer names showed up in that 23,000. And since it's a subquery, I can essentially say, okay, show me how many of these error classes had more than 2 user agents. Okay? So back to the query and the idea. So during the morning retros, we realized that single customers can cause error spikes. I mentioned that that's a common problem, right? For a moment, ignore the bits about customer name. We're going to pretend that we don't have any customer data in NRDB. And we don't know how to add that yet, okay? And put on your imagination glasses. So, so if we don't have customer data, what can we do? Maybe we could do user agents and say, like, all right, if a Go client and a Ruby client are both having problems, that indicates that there could be like something actually happening. If it's just the Ruby client or just one Mozilla client, maybe it's just one customer, right? So like maybe user agent is a reasonable proxy for customers until we have that data. So we implement that. We restrict that class and say only if it's got greater than or equal to user agents. I don't know if you can see it on the slide, but that orange line underneath it, there's like a tiny improvement. I don't know if it's enough, but it's like, okay, whatever, it's good. Maybe we could do better. So let's try and do better. let's think about like how could we add, the original goal was to identify how many distinct customers are impacted. Maybe it's time we add some customer info. So we throw this little snippet in our application controller, New Relic agent.add custom attributes, and we just name it. Like this is all that's required to add more data to New Relic. It's like real easy. And then this is present on every transaction and transaction error event, which happens to be what we're using. So now we add that in. So we can say, all right, give me all the errors where the user agent is greater than equal to and where there's at least 3 customers having this problem. That seems reasonable, right? But the purple line at the bottom, I can tell you that it's slightly improved from the orange one on the previous slide, but it's not that much. So I'm sitting there thinking, like, what? I know this should work. What did I do wrong? I realized I just kind of pulled those numbers out of thin air, like 2 and 3. Why would that matter? So I was like, all right, let's do some stats. What actually is the maximum number that ever happens? This is like during a quiet week. There's no incidents happening. There's nothing interesting happening there. And it turned out at any given time, there were like 29 user agents and 141 distinct customers having problems. And apparently they're happy. They're happy to receive these error messages because they keep doing it. Like week after week, and they are just ecstatic to get error messages. I don't know, whatever. But I guess that's our baseline. So let's just reduce that. We'll do like a filter. And I'm going to tell you it works great. Well enough that on the next slide, I want to show you what an actual incident looks like. So this is what it looks like on an incident. I blurred out the lines, the timeline, because I don't really want to share when this happened. But you can see there's this, like, there's a lot of tricks you can do with alert conditions, but usually you don't get a perfect spike that aligns exactly with the beginning of the incident and exactly with the end. And that's just like, that's unheard of. This is a remarkable result, right? That, I have written here, that floor is so clean you could eat waffles off of it. Oh, gross. But I mentioned that we have to send this to Slack for a little while first because maybe it doesn't always work. So I was feeling very proud of myself when I wrote these slides until I saw another incident go by. And this is what I saw. I'm like, oh, great. So it just doesn't activate during real incidents. Huh. Okay, so maybe this isn't perfect. Like, this is what I mean. You have to verify these changes. This barely even activated at the height of the incident. So clearly I have more work to do. I don't know what happened yet, right? Like this is part of the gradual refinement process. We have to do this. So you may be tempted to think that this is just like a big company problem. You probably don't have 29 distinct user agents doing errors all the time, right? I know that I definitely thought so. In a smaller company like the one I used to work at, it's easy to dismiss problems as flukes. It is significantly harder when 141 people are content to have problems all day long every day. But when I look back, I think the number of incidents we had is actually kind of the same. And the type of incidents is fairly similar. It's just harder to ignore at my current company. And so I want to encourage you to think less about gradual refinement as like resolving some particular alert or some false positive. Think about it more like it's doing the research that you know you're going to have to do before you need it. So find me an incident where it's not useful to know how many customers are impacted. Honestly, is there one? That's just useful info. So don't think about it as resolving a thing. That's very easy to feel in that fluky camp. why bother refining that particular alert condition? It only happened once. Well, maybe that data is still useful. So I'm not going to go through this because I don't actually have time. Come to the booth. We'll talk about some alert conditions you could refine. I do want to say that all of these have the same fundamental limitation. A customer has to do something for us to see this data. And I don't know, show of hands, how many people have services that have like no traffic for more than an hour? Like, I know I do. I work in a giant company and I still have it. So like, what do? Let's make some traffic. So this is step 4, adding heartbeat monitors to add certainty to alert conditions. This is where we are in the map. This is the second biggest area I would spend money. These are really important, and they take time to do well. But they have such a big payoff. I'm going to demonstrate that to you. So the way I think about this, in my previous company, we had this PM who was super good at our app. Like, he knew every nook and cranny, and he could tell us when an incident was over. So if we were ever having trouble figuring out, like, okay, is the system really, really all back to normal? We'd call him in. And if it was late at night, he revealed that he had a version of his test called the 2 a.m. test. He's like, when I'm at work, he was willing to do a little bit more work, but at 2 a.m., he had a very minimal set of things he was going to check. That info is really important. So what if we could automate this? What if we could do it continuously, right? And that is what a heartbeat monitor is. It's headless JavaScript that acts like a customer. It can search, add things to the cart, check out, whatever you want it to do. It's a browser, right? And it is a fantastic way of determining customer impact. Like, it's tempting to think about heartbeats as something else, but like really, at the end of the day, if customer bot is broken, like customer is broken too. Like that's, you can put alert conditions on that and feel like real good about it. It also provides that handy point of filling out traffic at 3 a.m. when no one's awake. So it gives consistent traffic all throughout the entire day. So basically, it's an integration test, right? But constantly evaluated in production. That's pretty cool. You can. I haven't said this, I don't think, but I don't care if you use synthetics. I just care that you have something that's doing this for you, okay? And synthetics is the name of my company's product for it. So it's an integration test, but if any of you have written large integration test suites, you probably have a little like flag poking up right now, like, because we know integrated tests are a scam, right? This is a famous talk by J.B. Rainsberger, and the link is there on the bottom. But and he said he doesn't super love the tone of the talk anymore, but stands behind the principle. And I feel very much the same, except it is a really catchy title. So these have many of the same problems. They're expensive to build and run. They're error prone. They actually add load to your servers, unlike integration tests. They're hard to get around things like auth, which you can actually do more easily in an integration test because you can mock stuff out. You actually have to deal with that problem now. So we have to restrict ourselves. And my recommendation here is you get 1 per 1,000 lines of code. Maybe 2, if you only have 1,000 lines of code. This is actually our service. Like, I don't know if this is down. How do you even know? Well, this is what it looks like with synthetics. Like, yeah, no, it's not down. This is huge, right? I like this title. Learning to trust your heartbeats. I'm not going to lie, it is hard to trust them sometimes, even for me. So while I was writing this talk, I went to go get some slides and screenshots, and this is what I found. I'm like, oh, great. This is exactly what I needed right now. this is a staging app in our company, in a monitoring company. Like, stuff happens. This isn't a big deal. But it's not ideal that for whatever reason I had 0 telemetry. Activity, just yell out, what do you think I did at this point?
Nothing.
Nothing. OK, someone said restarted things. That's good. Anyone think I checked the synthetics robots? Yeah, that would be very smart. That is not what I did. I restarted things. I looked at a whole bunch of config settings. I wasted about 2 hours. So yeah, that's not what I did. But had I done that, and when I finally did remember that, I went to the synthetics page and saw this nice little note. Everything's OK. Like, OK, telemetry is missing, but the robots are happy. It's probably just telemetry. I'm going to reboot some stuff, and like, yeah, it came back immediately. But even I, the person telling you you should use heartbeats, forgets to use them. So it is hard. They also work for other things, not just web services. If you have a background system, make a heartbeat job. Ours doesn't do anything. It just gets processed. But the fact that it's getting processed means that I have background workers that are still alive. That's important information to have. You can do it with an email system. You can do it with an external service. That one's really fun. We used to work with Experian, and they were always down. And it was really great to be able to, yeah, my old coworkers laughing about that one. Yeah, so you can attach a heartbeat monitor to third-party services. They may not like it, but it is very helpful. So this is kind of the phrase I use at work a lot, and my coworkers will laugh, I think. How do you know the system works? Use it, find out. That's what we're trying to do. So I've got 3 minutes left. That's excellent. This is like a huge topic. So upper right corner is my mailing list. It is not a company thing, it's just me. I'm going to post some blog posts about some details because there is some missing documentation on the internet, and I would love for you to have it. So, yeah. So the first thing, deploy fewer things more often. You all know you're supposed to do this. It is hard. In order to do it, you have to get CI that can do everything. You have to get those alert conditions really dialed in, and you have to start working on dark deployment. All of those things are Googleable. They're all actionable. But I will say that in order to get here, you actually have to have dealt with your alert conditions before. You have to have heartbeats. You have to have built trust in order to convince your bosses that automatic deployment is going to go OK, and we're going to find out if it didn't work, right? Like that is a hard conversation to have if your boss or bosses don't have trust that the system is going to tell us if something happened. Once you have automatic deployment, you can take advantage of something called canary deployments. This is very common in Kubernetes. It's basically you have your main fleet, and then you have a couple extra servers on the side. They're still in the same load balancer, but those couple extra servers are running a different version of the code. Now you can compare between the two. If the error rate goes up on the canaries, so you deploy the canaries first, and then you deploy to the main fleet. If the error rate goes up, don't deploy to the main fleet. Roll back. You don't even need to have an alert notification. Just roll back. Maybe send a Slack notification. Shit's broke, you know? OK, third one. This is really important. Just go install Semian. Like, Semian should be in every single Rails app. Circuit breakers are solved. Like, stop writing circuit breakers. And it sets you up for Semian's bulkheads. This is the one that I really want to send you a blog post about. Circuit breakers catch fast network failures very well. They are very bad at catching slow network failures. Bulkheads make slow network failures fast. And so they work with circuit breakers again. And tuning these is obscene. So that's why I want to get those docs online. So wrap-up time, 3-point takeaway. Hopefully you understand these now, right? Notifications deserve retros. You have to get that data. Default alert conditions require refinement. And heartbeat monitors save lives and are worth attaching alert notifications to. This is my map for your team. Wherever you're in it, this is how much time and the order in which I would go about things. So that's my talk. Thank you.